Section 12.3a is about multiplying rational expressions. Rational expressions are expressions that involve variables and numbers, exponents, and we're going to learn to multiply those and what we should do. The key to this is when you multiply numerators and denominators, you may cross-cancel to simplify. And when I say cross-cancel, some people think that that only means that I can cancel things across on a diagonal, but that's not true. As long as you're multiplying everything, you can multiply any factor on the top with any factor on the bottom, even across the multiplication symbol. For example, I see a 5 here. I'm going to cross that out because 5 goes into 15 3 times. So I reduce the 5 to a 1 and the 15 to a 3. I also see an 8 here that goes into 8 once and into 16 twice, so I can reduce that. I see an a and an a squared, so I'm going to cross one a out, and I'm going to cross one of these a's out here, leaving one behind. Here I see a b that it can cancel with two of these, leaving me with a b squared. And then finally, c squared will cancel with two of these three, leaving me one c on the top. So on the top, I'm left with just a b squared. Oh, there's a 2 there also, so the 2's got to go in front. So 2b squared c. And on the bottom, I have a 3 and an a. So that's how that one would simplify. Obviously, you have to be very careful when you cross things out. There's a lot of slash marks here. Some people like to completely remove things by scribbling them. You might want to write them a little bit bigger, whatever works for you. But the point is you can cross-cancel any factor on the top with any factor on the bottom. Here's another example of multiplying rational expressions. What can we cancel? I see a 10 and a 15. 5 goes into 10 twice and into 15 3 times. I see that 4 goes into 12 3 times and into 16 4 times. But that also means that 2 and 4 can be canceled. 2 goes into 2 once and into 4 twice, and then the 2 3's will cancel each other out. So that's going to leave me with just the number 2 on the top. Now let's get to the letters. You can do this a couple ways. I see an s squared and an s on the top, meaning that there are 3 s's completely on the top. And I see an s and an s cubed down here, which means there are 4 s's down on the bottom. So for me, I'm going to cross off all 3 of the s's on top and get rid of that s cubed, leaving me that single s on the bottom. As far as the t's go, I see 3 of them, and then 2, so 5, and then I see 4 down here. So I'm going to cancel the 3's and this t with one of these t, leaving me a t on top. And let's just review. I got all my numbers, 2 on the top with a t and an s on the bottom. So I'm done. Now we're going to get into simplifying these expressions, but now we're going to use addition and subtraction and show you what kind of problems that creates. After having done the last couple of examples, people will look at this example and say, oh, I must be able to simplify this 5 and this 15 and create a 3 down here. But that would be incorrect, and I want to show you why. It's okay to cross-cancel as long as you're cross-canceling factors, things that are being multiplied. This x minus 5, that's a binomial factor. The x and the 5 are connected with subtraction. So you cannot cancel any piece of this. I couldn't cancel this x with this x. That would not be legal because the x on top is connected to the 5. But one thing that I can do is I can take these polynomials and I can attempt to factor them. So I'm going to do that. I'm going to rewrite this using the pieces that are already factored. But this time I'm going to take this trinomial and use our diamond. Now I'm not going to do a diamond for every single one. Hopefully you're going to be able to do the diamonds on your own. But for this one, I'll find 2 factors of negative 15. That had to be negative 2. Looks to me like negative 5 and 3 will work. So I'm going to go down here and I'm going to factor that trinomial into x minus 5 and x plus 3. Now by doing that, I've created 2 binomial factors. These are groups that are being multiplied. And I can cancel the entire group. What I can't do is cancel just the x and just the 5, or just the x and just the 3. So let's see what we can cancel. I can cancel this x here with one of the x's there, and I can cancel the x minus 5 with this x minus 5. That's legal, because you're taking the entire factor. So what's left? X over x plus 3. That's as simple as I can make it. Again, can't cancel the x and the x because the x is connected to the 3 with addition. Here's another example using polynomials. The trick to simplifying these is to factor first. So here you see a trinomial that I'm going to factor using the diamond. Hopefully you can do this one in your head. 2 factors of 10 that add to be 7, a plus 5 and a plus 2. If you can't do that in your head, it's fine if you use the diamond. Here a plus 1, and then over on this side, this top has a GCF of a 3 that I can pull out, and you should do that. You should try to factor in any way that you possibly can. And so now that everything is factored, everything is broken up into groups, I now want to look for things that will cancel. Well, I see an a plus 2 and an a plus 2, a plus 1 and an a minus 1, or excuse me, a plus 1, leaving me with a 3 times a plus 5. Now that's a fine answer. The other thing I could do is distribute the 3 and make it 3a plus 15. Either one of these answers is acceptable. Here's our last example using polynomials. You may want to pause the video, do all the factoring and canceling, and then come back and see how you did. So rewriting this, x minus 5 on the top. This one, x minus 5 and x minus 2, because negative 5 and negative 2 multiply to get 10, and they add to be negative 7. Here, 2 factors of negative 6 that add to be 1 are 3 and negative 2, and then the 5 on the bottom. Cancel the x minus 2's, cancel the x minus 5's, leaving x plus 3 over 5.